This is the first of two videos where we're going to solve logarithmic equations using the rules for logarithms. So you've just been practicing these three rules, the product rule, quotient rule, and the power rule. We've used the power rule a little earlier to solve certain types of equations. So in this video we're going to be concentrating on using the product rule and the quotient rule. Before we actually start solving a lot of equations, though, we need to discuss a strategy when you have a variable in your denominator. So often with these types of problems, you'll end up with a rational expression, and there'll be a variable in the denominator of that expression. For instance, you might end up with a form like this. Now, we haven't really worked with this exact type of equation before, but I hope you're comfortable that the idea here will be to, in this case, multiply both expressions by n. That way we can reduce this factor of n to a factor of 1, and the left side will simply be 6. Of course, we have to multiply the right side by n also, but once we reduce that factor of 1, we'll get 2n equals 6, and then we can just divide both sides by 2 and find that n is 3. Try this one. Here I'd want to multiply both sides by y. On the left, the factors of y reduced to a factor of 1, and I'll just have 1 times 4 divided by 1, so that'll just be 4. I have to multiply the right side by y also. And now over on the right, I need to divide by 100, so I'll do that. I'll divide both of these by 100, and this will reduce to a factor of 1, and I'll just have that y is 1/25. If you prefer decimals, you could say it's 0.04. How about if it's a binomial? See if you can figure this one out. In this case, we'd multiply both sides by x plus 2, and then once we reduce this factor of x plus 2, we'll have 20 is equal to 5 times the quantity x plus 2. Now you could distribute here, and that's fine. I'm just going to divide both sides by 5 though, and I'll have x plus 2 equals 4, and after subtracting 2 from both sides, I'll have x equals 2. And here's one more. After multiplying both sides by t minus 2 and reducing the common factor of t minus 2, I'll have 2t minus 5 equals t minus 2. Make sure you've also multiplied t minus 2 to the right side. And now to solve for t, I'll just subtract t from both sides and get t. I'll add 5 to both sides and get 3. And I can see that t is going to be 3. Let's put it into practice now. I'll do this first one, and then there'll be one for you. Now I notice that I have a difference, and so I'm going to use the quotient rule and rewrite that difference as a quotient. Now I've got a couple of choices here. I could use both of these expressions as exponents for a base of 10, and that would be a fine approach. I'm just going to rewrite into exponential form. That is 10 squared equals 4 divided by y. And of course 10 squared is 100. And then I'm going to multiply both sides by y, so I'll have 100y equals 4 over y times y. So the y's will reduce here, and I'll just get 100 times y, and then I'll divide by 100 and get that y is 4 over 100, or 0.04. Here's one for you. After using the quotient rule to rewrite the difference as a quotient, if you want to raise both of these as exponents for a base of 3, that will work. Again, I'm going to rewrite into exponential form. 3 squared equals 18 over x, and of course 3 squared is 9. I'm going to multiply both sides by x, and so I'll get 9x equals 18 after I reduce. And then I'll divide both of these by 9 and get that x is 2. Well, that will conclude this first video. where we've solved equations that had a variable in the denominator.